Good day, ladies and gentlemen. We are now going to be looking at AC circuits. So we know that in an AC circuit, we have an RL circuit, an RC circuit, and an RLC circuit. But specifically for this video, we are going to be looking at RL circuit. So let's get on.
Before we get into our RL circuits, I want us to understand the difference between AC and DC. So we know what the current is the flow of electrons. The difference is that in a DC circuit, the current is just flowing from negative to positive, from negative terminal to the positive terminal, straight like that. They do not alternate or nothing. They just flowing from positive terminal to negative. I will try to put on another video or an animated video which talk about to explain the difference much further than this. You can check on the link below. But in an AC circuit, an AC alternating current, the electrons are flowing left, right, from negative to positive, negative to positive, negative to positive, side by side, you can say that. So how do I, if I can put this in a sketch, this, let's say this is your voltage, a direct current voltage. So it's straightly flowing from positive to negative. There is no changing in voltage or changing in current. It just flows from positive to negative. But now, when we come to your AC, it's going to flow to a maximum positive value and to negative maximum negative value. So this Vmax and Vmax, negative and positive. So it's going to flow from positive terminal, from positive y-axis to negative y-axis. So alternate current is flowing from positive to negative, and it is generated in an angle which is from 0 to 360 degrees. One cycle is from 0 to 360 degrees. So this is going to play a very important role when we are talking about the capacitance and the inductance reactance. So now let's quickly get into business. So an RL circuit look like this. This is your AC source. This is your R, and this is your inductance, this your V source. So now, since as I've said that the AC is generated from 0 to 360, when the current passes through this through the resistor, we found that the voltage waveform, or the voltage is in phase with what? With the current, this being the voltage VR and this being the current IR. The voltage is in phase with the current when it passes through the resistor. What does this mean? This means that the voltage will finish one cycle in the same time. Like I've said here, one cycle is 360. So the current and the voltage, they finish one cycle 360 in what? In the same time. There's no difference between that. But now when it comes to pass through the inductor, this is your resistor. But now when the current passes through the inductor, now it's different this side. The current is going to be lagging the voltage by 90 degrees. This will be your voltage, so you see this is going to be your 90 degrees, the difference. So you see the voltage VL, this one. Okay guys, now so we can say that the voltage passing through the inductor finish its cycle ahead of the current that is passing through the inductor. So the current is lagging, the current is behind the voltage in terms of finishing what? The cycle. That's why we say the current lag the voltage in an inductor. But in a resistor, the current and the voltage, they finish one cycle at the same time. So because of this difference in the voltage and the current in the inductor, the current flowing in the inductor will be in the opposite direction. So now when analyzing, or when the voltage is passing through this, the current and voltage pass through the inductor, it doesn't see the inductance, but it sees the reactance of the inductor. And the reactance of the inductor is calculated using the formula 2 pi FL. The inductance is noted using XL, the inductance reactance, the reactance of the inductor. Using SL, this is the frequency of the supply voltage, and this is the inductance of the inductor. So now what the voltage now see, what the voltage source see, it see both the inductor and the resistor, both the inductor and the resistor, and the combination of both the inductor and the resistor is called an impedance. So if we can put this in the sketch, the impedance, the reactance of the inductor SL is 90 degrees ahead of the value of the resistor. So now right here somewhere at a certain angle, that's where we get what? Our impedance, and our impedance is noted with the letter Z. So if we move the inductive reactance and put it on this side, we can have something like this. This is our R, this is our XL, and this is our Z. So now like this, you can see, what does this look like? You see, this is a triangle. So now since we have a triangle, that means we can use the theorem of Pythagoras, or the Pythagorean theorem, to determine the value of the impedance. So the theorem of Pythagoras, we know put the square root, Z is going to be R squared plus XL. So this is your your impedance across an RL circuit. So I want us to do one example. I want to be a little bit quick when doing this. Time is not on our side. Okay, now what does the statement say? The statement said, a coil with an inductance of 3 Henry and a resistance of 700 ohms is connected to a 200 volts 50 Hz AC source. Calculate number 1, the inductive reactance, number 2, the impedance of the coil, number 3, the value of the current through the coil, number 4, the phase angle between the voltage and the current. So there's something that I want us to note here. We can say this is a conclusion. We can say this is a conclusion before we get into this. Is sort of like a recall, actually. You can say this is a recall, or a conclusion, or a summary. It's a summary. In a series circuit, I assume that this you know, but let me just repeat it. in an AC circuit, the current passing through the circuit is going to be the same. So that one is also going to apply here. The total current IT is going to be the same as the current passing through the resistor and the current that is passing through the inductor, because this is a series circuit. So we can put it IT is equal to IR is equal to IL, and the voltage, okay, now the voltage is similar to the inductive, the reactances of the circuit, because now what the current passing through the inductor is going to be in the opposite direction of the IT, of the main current, and now the voltage is lagging, is no longer the same as is in phase with what, with the other voltage from the resist. So now when you calculate your VT, you want to reverse calculate your VT, is going to be, we're going to use the theorem of Pythagoras, VR squared plus VL squared square root. Number 3, the impedance R squared plus XL squared square root, and the angle can be calculated tan theta in terms of the voltage VL over VR, or in terms of cos theta VR over VT. So now can we quickly jump into an example? Where is our example? Okay. Here is our example. The first thing you must do is draw your circuit, or at least do your data. So if you're doing your data, but let's just do the circuit. I think the circuit is going to be much simple. (700 ohm), L is 3 Henry, the voltage 200 volts, 50 hertz. So let's calculate number 1, the inductive reactance. So the inductive reactance is going to be 2 pi FL. Sorry, XL is going to be 2 pi FL. This is 2 pi. What is the frequency? 50. And what is the inductance? 3. So you can punch your calculator. We get 942.48 ohms. Reactance are calculated in ohms. Number 2, the impedance. Calculate the impedance of the coil. Z is equal to R squared plus XL squared sorry, 700 squared plus 3 squared. So here we get 700 ohms. Now calculate the current through the coil. So guys, a coil, when we're talking about a coil is a conductor or a wire that has a resistance value and an inductive value. So that's why they say calculate the value of the coil. This is your coil. So a coil, if we measure here, we know that any wire or any conductor has a what? Has a resistance value. And since this is a coil, when you apply current, there's going to be the inductive reactance inside what? This coil. So they said calculate number 3, develop the current. So we're gonna use here Ohm's law. I T, because the current is the same throughout, as I've said before, V T over Z. We are using Z because Z is similar to R total, because what the battery or the source see, it sees what the total, the amount of the resistor and the inductive reactance. It sees both of them, and both of that is what is called the inductance. It doesn't see the inductance only or the resistor only, so we must use both of them. 200 over 700. We get 0.29 amps. So can you please squeeze the last one? Number 4, calculate the first angle between the voltage and the current. So the first angle is 10 theta. It's equal to, so we can use also XL over R. Sorry guys, there's no space. So when we to put this to it cross the equal sign, is going to be the inverse of 10 to the power minus 1. What's the value of XL? It's 942.48, and the value of resistor 700. So what's the angle there? Nine 2.48 over 7. It's 53.4 degrees. So if you have any question regarding this, please feel free to leave your question on the comments, or to just ask. I will answer you.
Okay guys, that's all for today. So please don't forget to hit the subscription button down there, or to hit the like button. And that's all for today. Enjoy your day.